Okay, today we're going to talk about a review topic about perfect squares and how to do square roots. So here we have a chart of all the perfect squares. Perfect squares are calculated by taking every whole number and squaring it, which means it's multiplied by itself. So 1 squared equals 1. 2 squared, which is 2 times 2, that equals 4. 3 squared is 9. 4 squared is 16. And we have that whole chart all the way up to 30 squared. Okay, this is a good chart to have at all times for this topic. So these are all perfect squares. So the square root of 64, 64 is right here. And the square root of 64 will take us back to what number was squared to get 64. So that's 8. Number 2, the square root of 36. 36, the square root of that is 6. Because 6 squared was 36. Square root of 49 is 7. Square root of 0, well, that's 0. Square root of 25 is 5. Square root of 1 is 1. Square root of 9 is 3. Square root of 4 is 2. Alright, so that's what happens when you have perfect squares underneath square roots. Now what happens when the number you're trying to take the square root of is not a perfect square? Well, you're going to have to simplify it by splitting it. So 18 would fall between 16 and 25. So 18 is not a perfect square. So what I need to do is I need to split this up into two radicals being multiplied by each other. The one on the left, I want to be a perfect square. So I have to ask myself what perfect square above where this is at. 18 falls right here. I'm going to check 16. 16 does not go into 18. 9 does. So 9 is the perfect square that divides into 18 evenly. 9 goes into 18 twice. Now, the square root of 9, I know, is 3. And the square root of 2 can come down, and that is called simplifying a radical. Let's try the next one. The square root of 72. So I'm going to break this apart into two radicals. Alright? 72 would fall right about there, between 64 and 81. So I'm going to ask myself, does 64 go into 72? No, it doesn't. Does 49? Nope. 36. 36 does. 36 times 2. 36 times 2 is 72. So the square root of 36, that comes out as just 6, and the square root of 2 tacks on to the end. So it's 6 square root 2. What happens when we have a number on the outside? Well, I'm going to deal with that later. I am going to break apart 45 like I did previously. And 45 is about right here. So what number above goes into 45 evenly? And that would be 9. This is 9 times 5. It's 45. Now this 5, I can just have it tag along with the rest of my work. The square root of 9 is 3. The square root of 5, can't do anything with that. And this 5 right here will drop down. And now I can multiply it. 5 times 3 is 15 square root 5. Let's try the last one. Again, I'll deal with this 2 in a little bit. So I'm going to break apart 200 because 200 would fall about right here. This is where 200 is. So I have to work my way up the list. And my goal is to find the biggest perfect square that goes into 200. And that would be 100. So 100 times 2. 100 times 2 is 200. This 2 is going to tack on to the end, and I'll deal with that later. Okay. The square root of 100, well, that comes out as 10. And the square root of 2 comes down. Now I can multiply my two numbers together. 2 times 10 is 20. And the square root of 2 is applied after that. Now we're going to multiply square roots together. So we have the square root of 10 times the square root of 2. Okay. Now neither of these are perfect squares. So what I'm going to do is I'm going to put these underneath one radical symbol. 10 times 2 is 20. Now I'm going to treat this like a problem I did earlier. 20 is between 16 and 25, so I know it's not a perfect square, so I'm going to split it into two radicals. What perfect square from this list goes into 20? That would be 4. 4 times 5 is 20. The square root of 4 is 2. And the square root of 5, well, that stays as the square root of 5. Let's try another one. This one's got a number on the outside, and it's multiplying two radicals together. So this 2, I'll deal with that in a minute. 2 times 12. 2 times 12 is 24. All right? Now I'm going to split 24. 2 times, I need to break this apart. 24 would be right here. So what is the biggest perfect square that goes into 24? Well, that would be 4. That's 4 times 6. So 2 drops down. We have the square root of 4, which is 2. And the square root of 6 drops down. And finally, we can multiply 2 times 2, which is 4, and tack on our square root of 6 at the end. Finally, we're going to divide. All right, we're going to see if we can divide two radicals. So, first we have the square root of 12 divided by the square root of 4. Now, I noticed that the square root of 4 is a perfect square. So I'm going to rewrite this as the square root of 12. Whoopsies. The square root of 12 divided by, well, the square root of 4 is 2. So, I'm going to take the square root of 12. Right? I know that I can rewrite that as the square root. I can split that into two radicals. And we still have that 2 underneath. So what perfect square goes into 12? That would be 4 times 3. The square root of 4 comes out as 2. And the square root of 3 tacks on. And then we still have division by 2. Now, these two divide. 2 divided by 2 is 1. So I can just cancel those, and I'm left with the square root of 3. Okay, next, neither of these are perfect squares, so one thing I can do here is I can divide those. The square root of 20 divided by the square root of 5, I can put that underneath one radical. That would be the square root of 4. 20 divided by 5 is 4. And I know the square root of 4 is 2. That one was pretty easy. Let's try another one here. This last one here, what happens when they don't divide each other? So the rule is you cannot leave a radical on the bottom of a fraction. So how do you do this? 5 divided by 2 doesn't divide. 3 divided by 2 doesn't divide. So what we have to do here is something called rationalize. Rationalizing the denominator. Now to do that, what we're going to do is we're going to multiply both the top and the bottom. Okay, we're going to multiply both the top and the bottom of the fraction by the square root on the bottom. So right now the square root on the bottom is the square root of 2. So I'm going to multiply the square root of 2 on the top and the bottom. Okay, so what happens is, on the top now we have 3 times the square root of 10. 5 times 2 is 10. On the bottom we have 2 times 2, and then we're going to multiply these two square roots, which gives me the square root of 4. Okay, let's continue this down here. Okay. Now, what happens on the bottom, say we have 3 times the square root of 10 on the top, and 2 times the square root of 4. Well, 4 is a perfect square, so that can be simplified. The square root of 4 is 2. Now we're left here, we have 3 times the square root of 10 divided by 2 times 2 is 4. Okay, 3 and 4 don't divide. And 10, well, 10 would be right after 9, but 9 and 4 don't divide into 10 evenly. 1 does, but it doesn't split it into two different numbers, so this is totally simplified. That's a quick lesson, quick review lesson on how to simplify radicals.